morning to all. Welcome to today's lecture. I am presenting lectures on microprocessor and microcontroller. Subject code is KEC 502. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to cover 8051 microcontroller, schematic pinout and pin description. So what is meant by this term schematic pinout? Let's see. In this pin diagram, we can see that all the signals have been grouped according to their functioning. Like here, this is lower order multiplexed address and data bus from pin number 0 to pin number 7 of port 0. This is pin number 0 to pin number 7 of port 1. These are the simple input-output ports. Now, this is the pin number 2, or pin number 0 to pin number 7 of port 2. These are the higher order address bus, that is A8 to A15. Here, pin number 0 to pin number 7 of port 3, this is port 3, this is port 0, port 1, port 2. So here port 3 represents the various functions supported by these pins like read signal, write signal, timers, interrupts, INT1 and INT0, transmitter and receiver pins. Here, pin number 18 and 19 is related to the clock generation for the circuit. Here the crystal oscillator is connected using our RC circuit to the two pins 18 and 19 of microcontroller. Here pin number 20 represents the VSS. Pin number 40 is for VCC connection. So in this way, in this schematic pinout, we can see all the pins, or we can say all the functions of the pins have been categorized according to their operations. So this is termed as the schematic pinout. So in subsequent slides, we will see all these pins. We will go into the details of all these pins one by one. So as we all know that 8051 is a 40 pin IC, and it is available in DIP package or 44 LED PLCC package or thin quad flat package. The pin orientation of an 8051 microcontroller may change with the package, but the pin configuration is same. So the basic image of the DIP, that is the dual inline package of 8051, is as shown. From pin number to pin 40, pin number 1 to 8 represents port 1. Then pin number 9 is RST. Pin number 10 to pin number 17 represents port 3, having the multiple functions as well as the simple input-output pins. 18 and 19 represents the connection of the crystal oscillator. Pin number 20 is the ground. Pin number 21 to 28 represents port 2. Pin number 29 is PSEN, that is a program store enable. Pin number 30 is address latch enable and PROG, that is the program connection. External access and the VPP is pin number 31. And pin number 32 to 39 represents port 0. And finally, pin 40 is the VCC. Let's go into details of all these functions. This is the representation of this IC in other two configurations, that is the 44 LED PLCC and 44 LED TQFP package. So pin number 1 to 8, that is a port 1. These are the port 1 pins. It consists of 8-bit bidirectional input-output port with internal pull-up registers. In older 8051 controllers, port 1 does not serve any additional purpose but just 8-bit input-output port. Now, in some of the newer versions, pin number 0 and 1 of port 1 acts as the timer 2 and timer 2 trigger input respectively. Pin number 5 and 6 of port 1 and pin number 7 acts as the in-system programming pins, that is MOSI, MISO and S clocks respectively. So, but this is available in few of the newer versions of 8051. But in the typical old version of 8051, pin number 1 to 8 of port 1 are just simple input-output pins. Pin number 9 is the reset input pin. It is an active high pin, that is, if the reset pin is high for a minimum of 2 machine cycles, okay, then the chip will go into reset. During this time, the oscillator must be running. Pin number 10 to 17 represents port 3 pins of 8051 microcontroller. Port 3 also acts as a bidirectional input-output port with internal pull-ups. Additionally, all the port 3 pins have special functions. The following table gives the details of additional functions. So we can see that pin number 0 represents serial input line. Pin number 1 represents transmitter line, that is a serial output line. Pin number 2 is the external interrupt 0 pin. Pin number 3 is the external interrupt 1 pin. 4 is timer 0 pin. 5 is timer 1 pin. 6 is write, that is the external memory write pin. And the 7 is the read, external memory read pin. So in this way, port number 3 has the multiple functions. Each and every pin of port 3 can be used for different purposes as mentioned in this table. So we can see that pin number 1 to 8 represents port 1, 10 to 17 represents port 3. Now we move on to another pins, that is pin number 18 and 19. We are reading these pins in sequence. So pin number 18 and 19 represent the crystal 2 and crystal 1 are the pins for the connecting external oscillator. Generally, a quartz crystal oscillator is connected here. Why quartz crystal? Because it has the highest accuracy among all crystals available. Pin number 20, that is the ground. Pin 20 is the ground pin of 8051. It represents 0 volts and is connected to the negative terminal of the power supply. In every IC, universally, in 40 pin IC, pin number 20 is your ground and pin number 40 is your that is the VCC. So we have to take this into note that pin 20 is always ground and pin 40 is always VCC. Now pin number 21 to 28 represents port 2. So this is the bidirectional port, that is all the port 2 pins act as the input or the output. And additionally, there is one more purpose, that when the external memory is interfaced, port 2 pins acts as the higher order address byte. Port 2 pins have internal pull-ups, similar to port 3. So port 1 is the only, port 0 is the only port which is not having its own pull-ups, and we have to connect the pull-up registers externally. So now pin number 29, that is the PSEN, program store enable. This pin is used to connect external program memory. That is, if we are by connecting this pin to the read pin or the output enable pin of external ROM, we allow the reading from the external memory. So this pin is referred to as the program store enable. That is, when externally the program is stored in the external memory, then it can be read by connecting the PSEN, that is the active low pin, to the read pin of or the output enable pin of external read only memory. Now next pin is ALE, that is the address latch enable. Pin number 30 is the address latch enable pin. Using this pin, external address can be separated from the data bus. As we all know that the lower order address bus is multiplexed with the data bus, and during the during the initial cycle of the machine cycle, the address is latched using this ALE signal, that is the When the ALE signal goes from low to high, then address is demultiplexed from the address bus is demultiplexed from the data bus. That is, the multiplexed address and data bus is used as the address bus in the initial cycle, and in the later cycles, this particular bus is used as the data bus. During the flash programming, this pin acts as the program pulse input, that is the PROG. Pin number 31 is external access bar, that is active low pin, and VPP. So external access enable pin, that is allows external program memory. Code from the external program memory can be fetched only if this pin is low. For normal operations, this pin is pulled high. So if we want to read the code from the external memory, then this external access pin should be activated. And to activate this pin, this should be made low because this is the active low pin. So for normal operations, this pin is high. So that is, this pin is deactivated. During the flash programming, this pin receives 12 volts programming enable voltage, that is the VPP. So the second purpose of this pin is during the flash programming. Pin number 32 to 39 represents port 0. So they are also bidirectional input-output ports, but without any internal pull-ups. Hence, we need external pull-ups in order to use port 0. So port 0 is the only port among all the 4 ports, that the port 0, 1, 2 and 3, these are the 4 ports, and among all these 4 ports, port 0 is the only port to which we have to connect the external pull-up registers to use those pins. In addition to acting as input-output port, port 0 also acts as a lower order address or data bus when external memory is accessed. So port 0 and port, as we have already discussed, that port 2 and port 0. These 2 ports are used to interface the address bus. Now last pin is pin number 40. It's the power supply pin to which the power supply voltage is given, that is the plus 5 volts. So we see that all the 40 pins have been discussed here. So next topic in 8051 is that I am covering today is addressing modes. So what is the addressing mode? Addressing mode is the way of representing the operands in the instruction set. So it is a way to locate target data, which is also called the operand. So the family of 8051 microcontrollers allows 5 types of addressing modes for addressing the operands. These are immediate addressing mode, register, direct addressing mode, direct indirect addressing mode, and register indirect addressing mode and indexed addressing mode. So these 2 are categorized under indirect addressing mode. Okay. So in total there are basically immediate, register, direct, indirect, and under indirect addressing mode there are 2 addressing modes, that is the register indirect and indexed addressing modes. So let's discuss these addressing modes one by one. So the first addressing mode is immediate addressing mode, in which the operand follows the opcode, that is the constant data of either 8 or 16 bits is represented in the instruction itself. For example, see this example, move A, comma, hash 030H. So this hash represents addressing mode. So that is the immediate addressing mode. So hash, the presence of hash in the instruction represents that the data over here is the direct data, and this has to be moved to the accumulator. So here the accumulator is loaded with the 30, that is the hexadecimal number, and hash in the operand indicates that it is the data and not the address of the register. This is the immediate data. So immediate addressing is very fast as the data is given in the instruction itself. Second type of addressing is register addressing, in which the data, that is the operand, is present in the registers specified in the instruction. Let's see. So we know that the organization of the RAM has been done into 4 banks, and within these banks, each bank is having the 8 registers. So in register addressing mode, one of the 8 registers is specified as the operand in the instruction. And it's important to select any of these banks according to the application, that we have to select these banks using the PSW, that is the 2 bits, pin number 3 and 4 of, that is a bit number 3 and 4 of program status word, that is the PSW register, helps us in selecting the particular bank. So before using any of the bank, we have to select the desired bank, and then we can use the registers specified in the bank itself. So in this example, R5 represents the register name, and the bank has been already selected using the PSW register. And the data given in this register, that is the R5, is copied to accumulator. So 8-bit content of the register R5 is moved to the accumulator. Bank 0 is given here because by default, as the system is reset or the system is powered up, but the default bank already selected is bank 0. Next instruction mode is direct addressing mode, and in this the address is directly given in the instruction itself. So this includes general purpose RAM, SFRs, input output ports, control registers. So data, according to this example, the data given at the memory location 47H is moved to the accumulator. Next is the register indirect addressing mode. That is, the address of the operand is specified as the content of a register. This will be clearer with an example. So here, move A, @R1, the symbol @, it indicates that the addressing mode is indirect. So the presence of this symbol indicates that the addressing mode used is indirect addressing mode, and the data given in the register specified in the instruction will act as the memory location, and the contents of that particular memory location will be treated as the data. So if the contents of R1 is 56H, for example, the operand in the internal RAM location 56H. So suppose the contents of R1 is 56H. So this will be treated as the internal RAM, and the contents given at this RAM location will be treated as the data, and those contents will move to the accumulator. So only R1 and R1 are allowed in such instructions as such addressing mode. So these registers in the indirect addressing modes are called as the pointer registers. Next is the indexed addressing mode. In indexed addressing mode, the effective address of the operand is the sum of the base register and an offset register. The base register can be either data pointer, that is the DPTR, or the program counter, that is the PC, while the offset is given in the accumulator. So in the indexed addressing mode, only move, see, and jump instructions can be used. Indexed addressing mode is useful in retrieving data from the lookup tables. So by taking this example, we can understand this, that according to this instruction, the contents of accumulator and the contents of data pointer are added. Those result of the addition of these two contents will be acted as the memory location, and the data given at that memory location will be copied to accumulator. So here the address of the operand is the sum of the contents of data pointer and accumulator. So in this way, this is known as the indexed addressing mode. So with this, I complete the pinout description of 8051 and the 8051 addressing modes as well. In the subsequent lecture, we will cover the address decoding and assembler directives of 8051. That's all for the day. Thank you.